After a few questions about the joystick switches, I thought I should try and measure the force needed to trigger the switch. With a little modification to my test stand, I set up a fixture to test the joystick switches. It's kind of crude, but I should get a pretty good idea of the force needed to press the switches. At the end of the video, I'll go over some of the details of the test setup. But basically, there is a green LED on the PCB that is to the left of the joystick. The LED will light when the switch makes contact, and for most of the measurements I will have the force gauge in the peak reading mode. So let me get to measuring. Let me start with the Alps joysticks that come in the DualSense. These are by far the most common joysticks used in the DualSense. I only have 3 new ones, but I have a few that I have removed from controllers that are in good shape. This joystick I'm testing here was removed from a controller, and this is the one with the most force needed to press the switch, and it tops out at 725 grams. Of the 3 new Alps joysticks I have, they were between 690 to 700 grams. Really a very tight spread considering how cheap these things are made. And of the 9 Alps DualSense joysticks I tested, the range was from 690 grams to 725 grams. That is a much tighter spread than I was expecting. I'm very impressed with that, really. This is an Alps joystick that goes into a DualShock 4 controller. I'm including it because I felt like it took a bit more pressure to click the switch. I only have 2 of these, so not a big sample size. And this is the weak one, almost 800 grams to activate the switch. The other one was about 840 grams, so quite a bit more force than the ones for the DualSense. Now that did surprise me. Seems like every time I do an in-depth test of just about anything, I learn something new. It's pretty easy to feel 100 grams of difference. Below say 50 grams, I find it much harder. Does this one take more force because it was made for the DualShock 4, or is it just this batch of joysticks? It is a lot more than any of the DualSense Alps. Here's the other joystick that might be found in a DualSense controller. These are made by Favor Union. This one seems to be about average for the Favor Union, around 650 grams. Out of the 15 I tested, the low was 635 grams, and the high was 674 grams. Again, a pretty tight spread. One nice thing about the Favor Union, there is a datasheet available, and it lists the switch pressure at 7 newtons, plus or minus 2 newtons. So a bit over 700 grams, plus or minus a little over 200 grams. Now that is a lot of pressure range. A switch at 500 grams is going to feel a world of difference compared to a switch at 900 grams. I would expect that if you order enough of them, you can get a tighter pressure range, and I'm sure the same thing would apply to Alps. Anyway, it looks like these Favor Unions run around 40 grams less than the Alps. Unlike Alps, Favor Union makes a Hall effect joystick, and I have a few of them. Out of the 7 I still have, the low was 664 grams, and the high was 723 grams. So this batch of joysticks is closer to the Alps switch pressures. There is a slight difference in the feel of the switch action. Pressure trip point doesn't tell the entire story, but I'm hard-pressed to distinguish between these and the Alps if I close my eyes. Now if Favor Union will just come out with a TMR joystick, all will be good in the joystick world. The GuliKit TMR and Hallpi TMR are still my favorite joysticks, mainly because of the GuliKit knobs. I'm confident the GuliKit and the Hallpi are the same joystick, so I'm putting them together here. This one being tested was the highest reading switch at about 680 grams. So with a test lot of 6 joysticks, the lowest reading switch was 604 grams and the highest was 681 grams. That is a noticeable difference that can be felt. If you happen to get a set at the low end of 600 grams, it will feel noticeably softer than the OEM joysticks in the controller. I only have a sample size of 4 for the K-Silver TMR joysticks. At the low end, 646 grams, and at the high end, 702 grams. This seems to be a pretty common range for most of the joysticks. I only have the 2 K-Silver Hall effect joysticks. This one that measured 700 grams, and this one that measured 755 grams. This was the highest reading for any of the DualSense joysticks. Only an Alps DualShock 4 measured higher. I believe these are some of the first Hall effect replacement joysticks that were available. I remember having a hard time finding them. And now for the Ginfull brand. I have 8 of the Ginfull joysticks with L-4G printed on red PCBs. I do believe Ginfull considers these V3 joysticks. This one was the highest reading of the 8 at around 627 grams. The lowest reading from this group was 530 grams, so a pretty large range. But these are very easy to move joysticks, very low tension, so switch pressure is really a little more than I was expecting. I only have 3 joysticks with the L4A printed on a red PCB, but I believe it's the same joystick frame as the previous version, and these pressures fell in the same range as the previous version. I have 8 samples with L4B on red PCBs. Again, I believe these are the same joystick frame as the previous ones, but the range for these 8 was a bit tighter, the low being 590 grams and the high being 621 grams. Now this is a Ginfull high tension joystick, labeled L4G on a white PCB. These were sold as V5 SE, but I believe Ginfull lists them as a V4 joystick. The confusion is bad enough that you really don't know what you are getting from a seller of these. These do require more force to move the joystick around, and that does translate to a higher overall switch force. Out of the lot of 17, the low end was 628 grams, and the high end was 678 grams. So while the lever movement of these joysticks takes a bit more force than the Alps, the switch force is overall still a bit less. And the final joysticks are the Ginfull TMR. These use the same frame as the high-tension Ginfull joysticks, though the ones I've used don't seem to have as high a movement tension. That may be just the batch I have. Of the lot of 7, the lowest switch force was 632 grams, and the highest was 685 grams. These are probably the best deal on TMR joysticks at the moment. All the TMR joysticks work very well, so it's down to the mechanical differences and the price to make the decision as to which one to buy. If you have to have the firmness of the Alps switch, I would say the best chance of getting that is probably the K-Silver TMR. The K-Silver Hall effect is too old, and I don't recommend using any Hall effect joysticks now. TMR is just too good. The Ginfull TMR would be the next closest. Looks like a pretty wide range of force needed to trigger the switch, but they're so cheap you could buy enough to sort through and pick out a couple you like the feel of. On the other hand, if you like a slightly softer feeling joystick, shaft movement and switch force, then the GuliKit / Hallpi TMR joysticks would be the choice. With over 80 joysticks to test, soldering wires onto switch terminals was out of the question. So I took a small piece of 1/2-inch PVC board, and using one of my joystick test boards as a template, I drilled out a hole for each pin of the joystick to fit into. That will work to hold the joystick in place, but I need electrical connections for the 4 switch pins. So I enlarged the switch pin holes to allow for a press fit of a socket pin. The PVC board is pretty soft, so I should be able to easily press the socket into position. I cut a channel in the back of the PVC board to allow for the wires from the socket pins. Each of the socket pins will get a wire attached. I think I could have gotten away with just 2 sockets, but the switch pins are not a tight fit in them. So I figured by using 4, I would stand less of a chance of having connection problems. The wires go through the hole in the PVC board, and then I try and start the socket into the hole straight. Even though the board is soft, it takes a bit of pressure to get the socket started. Then they get pressed fully into the board. They are almost flush, but not quite. The fixture gets clamped to my test stand, positioned so the joystick shaft is right under the force gauge's probe. My test stand is set up for pulling on wires, so I had to make some modifications. Switch travel is around 3/100ths of an inch, so I had to gear the movement mechanism down a lot. I threaded a 632 hole in a small clamp and used a long screw to push on a lever to move the force gauge down. Of course, the force gauge and mounting mechanism have enough weight of their own to activate the switch. To overcome that, I placed a spring under the movement mechanism, and that gave me quite good movement control for the force gauge. The force gauge is an MX Moon-free with a 1 gram resolution and an accuracy of plus or minus 1%. It's a cheap one from Amazon, but works quite well. The switch electronic connections go to a small MOSFET that switch the LED on and off, so the current on the switch is similar to that in a controller. Thank you for watching.